Hello everyone, my name is Manas Shukla and I am a third year student at online degree program at IIT Guwahati in the data science and AI degree. This is the term project 2 for the 8th trimester. I have built a spam email classifier using naive-bayes theorem. Now I will walk you through the code base, the results and the conclusion based upon that. Defining the problem statement. For my project, I built a machine learning pipeline to solve a problem we all deal with every single day: the overwhelming flood of spam emails. I made a classifier that automatically analyzes incoming text and mathematically filters out unwanted or malicious messages from legitimate communication. I chose to tackle this problem because spam is no longer just a minor annoyance, it is a massive productivity killer nowadays. Every year, billions of hours are wasted globally just sorting through junk emails. By combining natural language processing techniques, specifically TF-IDF vectorization, which is term frequency and inverse document frequency vectorization, with a multinomial naive-Bayes model, I created a fast, highly accurate system that isolates spammy words from natural human language. This project is highly relevant today because as digital communication scales, intelligent filtering becomes very useful to keep inboxes secure and usable. Now I'll be explaining you the tools and datasets. I have used Python as the core programming language because of its incredibly robust data science ecosystem. I have used Pandas, scikit-learn library. For data manipulation, I relied heavily on the Pandas library. As you can see here on the screen, Pandas allowed me to load the raw dataset structured into a data frame. Our dataset consists of thousands of sample messages and it is primarily divided into two crucial columns. Here I'll show you the dataset. It's divided into two columns, that is text and spam. So the spam is a binary column. The one indicates that the text is a spam email and the zero indicates that the text is a ham email. For the actual machine learning engine, I utilized scikit-learn library. These are the imports. This library is the industry standard for Python machine learning, and it provided both the TF-IDF vectorizer to convert our English text into mathematical arrays and the multinomial naive-Bayes algorithm for the predictive modeling. Leveraging these tools allowed me to efficiently build a highly accurate pipeline without having to hard-code complex algorithms from scratch. Now I will walk you through the code base. Starting the walkthrough in my training script, I first split the dataset 80-20 to ensure we have completely unsealed data for visualization. The most critical data decision was using TF-IDF vectorization with built-in English stop-word removal. This is the line. Instead of just flatly counting words, this mathematically scales our text metric so that rare, highly specific spam triggers carry much more weight than common vocabulary or grammar. Now, for the predictive engine, I implemented a multinomial naive-Bayes theorem. I specifically chose this algorithm because it is historically proven and highly optimized for discrete text features and word counts. When we call the fit function, the model calculates the baseline probabilities of spam versus ham and maps them against our TF-IDF vector space. So these are the lines that actually calculate the accuracy and precision score. So we can clearly see that the model accuracy score is around 90% and the precision score is 100%. The precision is the is a very highly important feature in this project. High precision ensures we minimize false positives, meaning the algorithm won't accidentally trap a user's legitimate urgent email inside the spam folder. Finally, I serialized the models and deployed them via Streamlit in the app.py file. This is done using the pickle library. I have also handled edge cases here. I added the validation logic to check the non-zero elements of the input matrix. If a user types complete gibberish that isn't in our trade vocabulary, the application safely blocks the prediction rather than blindly guessing, ensuring a robust user experience. Now I will walk you through the results. Let's let's first look at the data distribution. As you can see in this chart, our dataset naturally contains more legitimate emails than spam emails. This imbalance is exactly why we could not rely on accuracy alone and needed a more robust evaluation strategy. However, this perfectly mirrors real-world environments where spam emails are in minority class and they try to sneak in where a lot of legitimate emails are there. Before looking at the final numbers, this word cloud visually validates our TF-IDF model's logic. By plotting the most frequent words found exclusively in the spam dataset, we immediately see clear triggers like money, click, urgent, subject, will, etc. dominating the space. Our algorithms successfully learned to assign massive mathematical weights to these specific terms while ignoring conversational noise. Looking at the final quantitative metrics, the multinomial naive-Bayes model achieved a accuracy of 89.27. More importantly, we achieved a perfect 100% precision score. This metric is the absolute most critical result of the project. It mathematically proved that during testing, our model generated zero false positives, meaning not a single legitimate email was classified as spam. This is the Streamlit UI for the spam email classifier. Now we will test it for a spam and a legit email. This was a legit email and the model correctly classified it as legit. This is a spam email and it has been correctly classified as a spam email. Now I'll be telling you about the evaluation metrics. To evaluate model performance, we rely on a few core metrics. Accuracy simply measures the overall percentage of correct predictions our model makes. So our accuracy came out to be 89.27%. However, accuracy alone can be misleading if a dataset is imbalanced. For this, we calculated precision, which had a precision score of 100%. You may also hear about RMSE, that is root mean square error. It is important to note that RMSE measures the distance between predicted and actual continuous values, meaning it is used strictly for regression tasks, not for classification models like ours. Now I'll be sharing the summary and learnings for this project. To summarize, this project successfully delivered a robust machine learning pipeline that filters out unsolicited spam by applying TF-IDF vectorization and a naive-Bayes classifier. My biggest learning outcome was mastering how raw, unstructured human language is translated into mathematical arrays. I also learned that choosing the right evaluation metric is just as crucial as the algorithm itself, as it depends entirely on real-world consequences of making an incorrect prediction. For this project, the future scope could include that we can upgrade the pipeline to use deep learning models like LSTMs or transformers, where we understand the full contextual meaning of sentences rather than just individual word frequencies. That's all. Thank you from my side.